Hey guys, how's everything going? This is JSer. So in this video I'm going to solve 15A3 on LeetCode. It's easy one. Special positions in a binary matrix. Given a rows calls matrix mat, and the word mat ij is either 0 or 1, return the number of special positions. A position is called special if it is 1 and all elements in a row I and a column j are at 0. So for example, in a matrix like this one is not special because in this column there's another one. So this is another one. This one is special because in the row this is only one. This is only 1. Wow, this seems not to be difficult. We could say we could just create like what we did in the n queens problem. We keep a flag in a binary in a matrix. Say in this row and in this column. In two arrays. One array is for the columns. One is for the rows to keep track of how many ones are there, right? And then we could loop through each element. And say when you go this row, and we can count how many ones are there, right? And yeah, and for the this we could do the same for all the other rows, or for the columns, we could also count, right? How many ones are there? And after we did this, we have two rows, and we just filtered out the ones, right? You could do with a linear time and another 2 rounds, or we could just sum them up, right? And while we're looping through each row, we could get the number of one. Oh no. Okay, wait a minute. So, yeah. Let's just try to solve it with this naive solution and try to see if we can improve it or not. Okay, so we use suppose this one we have row. Oh, we could count 1, right? Okay, so const rows, count 1 rows, new. Okay, const rows equals mat dot length. Is there irregular input? And they will not be empty, so const of columns equals names.net. Yeah, so the rows will be new array rows field 0 const count 1 columns. We do the same. Okay, then we just loop through the elements, loop through the numbers. We need the index. Okay. So if it is 1, we will update the count of rows and columns, right? So count 1 rows, row plus 1, count 1 columns, column plus 1. So after all this, So while we could just loop through the matrix again and find the ones and check how many ones are there in the count one rows and count one columns, right? Yeah, so we looped it again. If it is 1, then you need to check if and if this is only one of it, and the columns also, if it's 1, we should let result equals 0. We plus it with 1. Well, this is a very naive solution. So finally we return the result. I think it should work. Wrong answer? Really? Okay. Like this. We like this one, right? We sum them up. So if this one, we column rows, column plus 1. So this is 1, 1, 1, 1, 2, 0, 1. Row, column 1 and columns rows, rows, 1 columns, shit. This. I think this should work. I'm not sure whether this is the best approach. Let's analyze the time and space. Time, yeah, it's 2n. N is the amount of the numbers, so it's linear time. Space, space, we say the rows, columns, so O-M plus N, right? Okay, this is actually, we say M is row, N is column, so O-M-N. Yeah, this is it. Hope it helps. See you next time. Bye-bye.